Bismillahirrahmanirrahim. Assalamu alaikum everyone. The quote of the day is environment is not asking us to conserve her for her, but for our future generations. The topic of today's presentation is air pollution and monitoring of air pollution under the supervision of Dr. Saira Afzal. The learning outlines of today's presentation is what is air pollution and its types, different air pollutants like carbon monoxide, sulfur dioxide, nitrogen dioxide, ozone, and particulate matter, and the natural and man-made sources of air pollution, effects of air pollution, indoor air pollution, monitoring of air pollution, prevention and control of air pollution, and air pollution in Pakistan, and at the end are the MCQs. By the end of this presentation, participants will be able to describe air pollution, its types, natural and man-made air pollutants, different air pollutants, how to monitor air pollution, and ways of preventing and controlling air pollution. Now, what is air? Clean dry air consists primarily of nitrogen that constitute about 78% and oxygen that constitute 21% by volume. The remaining 1% is a mixture of other gases that is mostly argon that is 0.9%, and other are the trace amounts of carbon dioxide, methane, hydrogen, methane, helium, water vapors, and others. Now, what is air pollution? Air pollution is contamination of indoor or outdoor environment by any chemical, physical, or biological agent that modifies the natural characteristics of the atmosphere. Air pollution, according to the WHO, air pollution kills an estimated 7 million people worldwide every year. Almost all of the global population, about 98%, breathe air that exceeds the WHO guideline limits containing high level of pollutants. Low and middle income countries are suffering their highest exposures. Now the types of air pollutants. Air pollution can be primary or secondary. Primary air pollutants are those pollutants that are emitted directly into the atmosphere from a source such as a factory chimney or exhaust pipe, or through suspension of contaminated dust by winds. Examples are carbon monoxide, nitrogen dioxide, sulfur dioxide, ozone, and others. And it is possible to measure the amounts emitted at the source itself, mean that the primary air pollutants are measurable. Now the secondary air pollutants. These are the harmful substances found in the atmosphere when a primary air pollutant reacts with substances normally found in the atmosphere like oxygen and water or with other pollutants. Example is the ozone. Because of this mode of formation, secondary pollutants cannot readily be included in emission inventories, meaning that it is difficult to measure their amount. Although it is possible to estimate formation rates per unit volume of atmosphere per unit time. Now the sources of air pollution, it can be natural or it can be man-made. Natural constitutes only a minor portion of the air pollution, while man-made is the major portion of the air pollution. Now the natural resources. Natural sources are organic compounds from vegetation, ground dust, salt spray from oceans, hydrogen sulfides from natural sources, cosmic dust, catastrophes like volcanic eruptions, forest fires, radon, fog, and mist. While man-made that are also called anthropogenic, are they are subcategorized into point sources, area sources, and line sources. Point sources are those that are forming from the industries, power plants, and oil refineries, while those coming out from the residential areas, apartments, office buildings, and hospitals and schools are area sources, while those coming out of the highways are the line sources. Now this is the diagram of the sources of air pollution. These are the man-made air pollution that are the industries and the vehicles and burning fuel at homes, while the natural sources are wildlife and volcanoes. Now the meteorological factors. Earth's atmosphere extends to several layers above the surface. Man is mostly concerned with 8 to 10 kilometers of atmosphere. Level of atmospheric pollution at any one time depends upon the meteorological factors like topography, air movement, and climate. If topography is dominated by tall buildings and mountains, the winds become weak and calm, and pollutants tend to concentrate in breathing zone. The vertical diffusion of pollutants depend upon the temperature gradient. When there is rapid cooling of lower layers of air, temperature, and that is called temperature inversion, there is little vertical motion, and pollutants and water vapors remain trapped at lower levels, and result is the smoke. that occurs in the mostly in the winter season when the temperature is low. Now these are the major air pollutants. These and that are categorized into primary and secondary. Secondary are secondary is mostly sulfuric acid, that is H2SO4, and ozone, while others are the primary like dust, lead, nitrogen dioxide, sulfur dioxide, carbon monoxide, dioxide, methane, benzene. Now the carbon monoxide. It is one of the most common and widely distributed air pollutant. It is a product of incomplete combustion of carbon-containing material, such as in automobiles, industrial processes, heating facilities, and incinerators. The sources of carbon monoxide, uh, as already described, are smoke coming out from the vehicles, forest fires, industrial emissions, power generations, and gas appliances, and the biomass burning. Estimates of man-made carbon monoxide emission vary from 350 to 600 million tons per annum. It varies with density of petrol powered vehicles, and most cities have carbon monoxide peak levels that coincide with monitoring and evening rush hour. Now, what is the mechanism of action that affects the health hazards? Carbon monoxide has higher affinity to bind with the hemoglobin than oxygen and carbon dioxide. So when it is in higher amounts in the atmosphere, it binds with greater affinity to the hemoglobin, forming carboxy hemoglobin that is cherry-red in color, and which causes the symptoms of carbon monoxide poisoning. The fluctuation in ambient concentrations is only reflected in the carboxy hemoglobin levels in humans, as it takes 4 to 12 hours for approximate equilibrium between air levels and blood levels to occur. Thus, environmental concentration tend to be expressed in terms of 8 hours average concentrations. The symptoms of carbon monoxide poisoning are nausea, headache, loss of consciousness, breathlessness, collapse, and dizziness. Now, how carbon monoxide affects the climate? When carbon monoxide is emitted into the atmosphere, it affects the amount of greenhouse gases which are linked to climate change and global warming. This means that land and sea temperature increases, changing to ecosystem, increasing storm activity, and causing other extreme weather events. Greenhouse will be further discussed in the next upcoming presentations. Now the sulfur dioxide. Sulfur dioxide, it is the source of man-made source is from the combustion of fuels. Natural sources are from the volcano eruptions, and the health problem it causes are the breathing difficulties and lungs inflammation, and it is also mm, the culprit of the acid rain. When it reacts with water, it forms sulfuric acid, A2SO4. Now, sulfur dioxide is one of the several forms in which sulfur exists in the air. The other include H2S, H2SO4, and sulfate salts. Sulfur dioxide is a colorless gas with sharp odor. It causes yellowish discoloration of Taj Mahal, and it also causes erosions of marble. It results from the combustion of sulfur-containing fossil fuel, the smelting of sulfur-containing ores, and other industrial processes. Domestic fires, power generation, and motor vehicles can also produce emissions containing sulfur dioxide. Now, the effect of sulfur dioxide on health. Sulfur dioxide can affect the respiratory system and the function of the lung. Inflammation of the respiratory tract causes coughing, mucus secretion, aggravation of asthma and chronic bronchitis, and makes people more prone to infections of the respiratory tract. It also causes the irritation of eyes, and the hospital admission for cardiac disease and mortality are increased. And there is increase on days with, and these are increased when the sulfur dioxide levels are high in the environment. Now, what is the health risk of sulfur dioxide? A sulfur dioxide concentration of 500 microgram per meter cube should not be exceed over the range of period of 10 minutes. Studies indicate that a portion of people with asthma experience changes in pulmonary function and respiratory symptoms after periods of exposure to sulfur dioxide as short as 10 minutes. Now the oxides of nitrogen, that are nitrous oxide and nitrogen dioxide. Emission of oxides of nitrogen occur predominantly in the form of nitric oxide, which comprises about 95% of nitrogen oxide from a combustion source. Coal is the most important fuel in this context. Other sources are road traffic and electricity generation. The pollutant of far greater concern in relation to human health is nitrogen dioxide. Epidemiological studies have shown that symptoms of bronchitis in asthmatic children increase in association with long-term exposure to nitrogen dioxide. Reducing lung function growth is also linked to nitrogen dioxide at concentrations currently measured or observed in the cities of Europe and North America. Now, what are the signs and symptoms of nitrogen oxide poisoning? Uh, these are the eye, nose, and throat irritation and breathing problems and coughing up blood. The current WHO guideline value of 40 microgram per meter cube annual mean set to protect the public from the health effects of gaseous nitrogen dioxide remains unchanged from the level recommended in the previous air quality guidelines. Now the ozone. Ozone at ground level, that is not to be confused with the ozone layer in the upper atmosphere, is one of the major constituents of photochemical smoke. The highest levels of ozone pollution occurs during periods of sunny weather. Ozone in upper atmosphere, it is also called the good ozone because it protects the earth from the ultraviolet radiations and harmful radiations from the sun, while the ozone that is formed by photochemical reaction on the earth's surface is harmful to the health. Ozone is composed of 3 oxygen molecules. Now, how ozone is formed? Ozone is formed by the chemical reaction of nitrogen oxides and volatile organic compounds in the presence of sunlight. Ground level or bad ozone is not emitted directly into the air, but is created by the chemical reactions of nitrogen oxide and volatile organic compounds in the presence of sunlight. Emissions from the industry facilities and electrical utilities, motor vehicle exhaust, gasoline vapors, and chemical solvents are some of the major sources of oxides of nitrogen and volatile organic compounds. Now, how ozone affects the health? When ozone is inhaled, it causes inflammation uh, in the respiratory tract and in the alveoli, which causes breathing symptoms, worsening of the lung functions like asthma and emphysema exacerbation, and increase emergency visits and hospitalizations, missed work and school days, and heart attack, as these are occurring nowadays. In Europe, it is currently one of the air pollutants of the most concern. Several European studies have reported that daily mortality rises by 0.3% and that for heart disease by 0.4% per 10 gram per meter cube increase in ozone exposure. The previously recommended limit, which was fixed to 120 microgram per meter cube of 8 or mean, has been reduced to 100 microgram per meter cube based on recent conclusive associations between daily mortality and ozone levels occurring at ozone concentrations below 120 microgram per meter cube. Now the particulate matter, that is also a major air pollutant. It consists of a complex mixture of solid and liquid particles of organic and inorganic substances that are dispersed into the atmosphere. The major components of particulate matters are sulfate, nitrates, ammonia, sodium chloride, black carbon, mineral dust, and water. Particulate matter sizes are important uh, for causing the health hazards. Particles are generally classified by their size measured in micrometer. Micrometer is the 1 millionth of a meter. Particulate matter 10. Particulate matter 10 indicates that the particulate matter is of 10 micrometer in size. Includes those inhalable particles that are sufficiently small to penetrate to the thoracic region, while particulate matter of 2.5 micrometer size have a size fraction with a high probability of deposition in the smaller conducting airways and alveoli. As shown in the figure, the particulate matters that have the diameter of less than 10 micrometer are in larger size, while those that are of 2.5 micrometer are smaller size. This is the, for comparison, this is the human hair, and these are very small in sizes. The PM10 particle matters cannot lodge into alveoli. They can lodge in the upper airways like larynx, trachea, and bronchi, while the PM 2.5 will go deeper to the alveoli and cause more serious health hazards. WHO air quality guidelines for particulate matter. For PM 2.5, the annual mean is 10 microgram per meter cube, while for 24-hour mean it is 25 microgram per meter cube, and for PM10 the annual mean is 20 microgram per meter cube, and for 24-hour mean it is 50 microgram per meter cube. The air quality guidelines for PM10 is higher than the PM 2.5 because it is more dangerous than the PM10. These particulate matters can also cause health hazards in lower concentrations than given in the WHO guidelines, but there is no threshold where these cannot cause health hazards. These are the acceptable limits. Now the health hazard for particulate matter. First is the particulate matter of 2.5 micrometer in sizes. It is more hazardous as it penetrates deep to bronchioles and alveoli and thus interfere with the gaseous exchange. Short-term exposures up to 24 hours duration have been associated with premature mortality, increased hospital admissions for heart or lung causes, acute and chronic bronchitis, asthma attacks, emergency room visits, respiratory symptoms, and restricted daily activities. These adverse effects have been reported primarily in the infants, children, and older adults with pre-existing heart or lung diseases. And the long-term effects, when its exposure is from months to years, has been linked to premature death, particularly in people who have chronic heart or lung diseases and reduced lung function growth in children. Now the particulate matter of 10 micrometer in size. Short-term exposure have been associated primarily with worsening of respiratory diseases, including asthma and COPD, leading to hospitalization and emergency department visits. The effects of long-term exposure to PM10 are less clear, although several studies suggest a link between long-term PM10 exposure and respiratory mortality. The International Agency for Research on Cancer published a review in 2015 that concluded that particulate matter in outdoor air pollution causes lung cancer. Now coming towards the indoor air pollution. The indoor environment represents an important microenvironment in which people spend a large part of their daily time. As a result, indoor air pollution originating from both outdoor as well as indoor sources is likely to contribute more to population exposure than the outdoor environment. Common indoor air pollutants are like moistures, volatile organic compounds and chemicals from the perfumes, body sprays, and different beauty products, smoke from the smoking, the dust from the carpets and while cleaning the floors, and the pet feathers and danders. Now the sources of indoor pollution are from the combustion of fuels while cooking, when the ventilation of the indoors are poorly ventilated. uh, Freshly painted rooms are also a source of air pollution as it also contains harmful air pollutants like lead and the sentient atoms that contains volatile organic compounds, pet danders and feathers. If there are more people in the house, there will be more concentration of gases, and the major culprit of the indoor air pollution is the smoking. This is the also the sources of indoor air pollution. Um, these are the air pollutants and these are their sources, like the carbon monoxide source is fuel and tobacco combustion, while that of nitrogen oxide is fuel combustion. Sulfur and arsenic and fluorine are the sources are the coal combustion, while for aldehydes the sources are furnishing construction materials and cooking, and for asbestos there is remodeling and demolition of construction materials, and for lead the sources are remodeling demolition of painted surfaces. Now this is a diagram we show the three danger levels of indoor pollution. These are categorized into three danger levels, 1, 2, and 3. In danger 1, there are the allergens and the particulates like dust and pollens, molds and fungi, and pet allergens that causes various health effects like nose and throat irritation, runny nose, congestion, sneezing, cough and wheezing, and asthma flares. While the danger to air pollutants are infectious agents, which includes bacteria, fungi, and viruses that causes various health effects like sinusitis, upper respiratory tract infections, bronchitis, pneumonia. While the level 3 that are most dangerous are the toxic compounds like formaldehyde, carbon monoxide, nitrogen dioxide, lead, mercury, and others. They cause serious health effects like memory lapse, mild depression, lung dysfunction, blood vision, headaches, and lethargy. Mm, these are already discussed, and these are the deaths related to the indoor air pollution. About 4.3 million deaths occur annually due to indoor air pollution. Always the greatest contribution is due to the stroke, that is 34%, and the persons dying due to indoor air pollution due to chronic heart disease are 26%, and for COPD are 22%, and the persons dying from indoor air pollution are 6%, and from pneumonia are 12%. Now the effects of air pollution. These are categorized on human health, on plants, on climate, and others. First one is the on human health. Air pollution causes irritation in the respiratory tract, eye, nose, throat. Pollens cause asthmatic attack. Mercury results in kidney, nerve, and brain damage. Carbon particles through cigarette smoking causes cardiovascular disease, kidney and liver damage, and even death. These are the various air pollutants. These are their sources and these are their adverse effects. Like ozone, it is a sources from the automobile exhaust and high altitude aircraft cabins as already discussed. It causes respiratory track problems. Sulfur dioxide, as already discussed, it comes from the power plants, smelters, oil refinery, kerosene, space heaters. It causes exacerbation of respiratory tract symptoms and causes increased hospitalizations and emergency room visits. While the lead that comes from automobile exhaust using lead gasoline and from the paints, it causes impaired neuropsychological development in children like impaired or low intelligent coefficient and low social development or antisocial behavior in the children's. Now the effects of air pollution on plants. Sulfur dioxide bleaches the leaf surfaces and causes chlorosis. Chlorosis is the yellowing discoloration of the leaves. Nitrogen dioxide causes premature leaf fall. Ozone causes necrosis and damaging of the leaves, while peroxyacetyl nitrate is responsible for suppressed growth, silvering of lower leaf surfaces. The effects on climates are increase in carbon dioxide content of the atmosphere, global warming, melting of ice and glaciers, thinning of ozone layer, penetration of UV rays due to damaging of the ozone layer in the upper atmosphere and the acid rain. While on aquatic life, and the air pollutant mixing up with the rains causing acidity in freshwater lakes, affecting aquatic life, especially the fish. Now the monitoring of the air pollution. The best indicators of air pollution are sulfur dioxide, smoke, and suspended particles. These are monitored on daily basis over several sites. The results are then collected by a central agency and then they are sent to the concerned department in various countries where they are monitored. Now, how sulfur dioxide is measured. This gas is a major contaminant in many urban and industrial areas. Its concentration is estimated in all air pollution surveys. Smoke or swallowing index. A known volume of air is filtered through a white filter paper under specified conditions and the stain is measured by a photoelectric meter. Smoke concentration is estimated and expressed as micrograms per cubic meter of air as an average level over a period of time. Grit and dust measurement. Deposit gauges collect grit, dust, and other solids. These are analyzed on monthly basis. Now the coefficient of haze. This is a this factor is also used, particularly in the USA, in assessing the amount of smoke or other aerosol in the air, as it causes decreased vision. Now the air pollution index. It is an arbitrary index which takes into account one or more pollutants as a measure of the severity of a pollution. Now the examples where air pollution monitoring is done. The following index has been used in United States. In United States, 10 times the sulfur dioxide concentration plus twice the carbon monoxide concentration, both in uh, mm, parts per meter by volume, plus twice the coefficient of haze. It was considered to be cause of alarm when the value of index rose from its value of about 12 to 1550 or more. Now the guideline values for individualized substances based on effects other than cancer or odor. WHO in 1987 in its publication Air Quality Guidelines for Europe and more recently in 2005 edition has described approved method for determining the concentration of common air pollutants and their health hazards. The emphasis in the guideline is placed on exposure since this is the element that can be controlled to lessen the dose and hence lessen the response. The starting point for the derivation of guideline value was to define the lowest concentration at which adverse effects are observed. On the basis of the evidence concerning adverse effects, judgments about the protection factors need to minimize health risks were made. Averaging times were included since the time of exposure is critical in determining the toxicity. This table shows the maximum upper limit with every time. And this is a table for various air pollutants, and it also shows the every time when it exceeds this time in this highest limit, it will cause the health hazards. These are their values, and these are their maximum higher acceptable limits, and this is their acceptable every time periods for different uh, air pollutants. Now, the prevention and control of air pollution. The methods for controlling gaseous pollutants. The air pollution caused by gaseous pollutants like hydrocarbons, sulfur dioxide, ammonia, carbon monoxide, and others can be controlled by using three different methods like combustion, absorption, and absorption. In combustion method, the organic air pollutants are subject to flame combustion, which convert them to less harmful chemicals like carbon dioxide and water. The other is the absorption. In this method, polluted air containing gaseous pollutants is passed through a scrubber containing a suitable liquid absorbent. The liquid absorbs harmful gaseous pollutants present in the air. The third is the adsorption. In this, the polluted air is passed through a porous solid adsorbents kept in suitable containers. Gaseous pollutants are adsorbed at the surface of solid porous and clean air passes through. Now the method of controlling particulate emission. These are the mechanical devices. They may be wet scrubbers, electrostatic precipitators, and fabric filters. The mechanical devices work by either by gravity or sudden change in the direction of airflow. In gravity method, in this process, the particle matter settles down by the action of gravitational force and then eventually gets removed. In sudden change in direction of airflow, it brings about separation of particles due to greater momentum. And in wet scrubbers, these are used to trap sulfur dioxide, ammonia, and metal fumes by passing the fumes through water. And the electrostatic precipitator. When the polluted air containing particulate matter is passed through an electronic precipitator, it induces electric charge on particles and then the aerosol particles get precipitated on electrodes. And the last is the fabric filters. In these work like the filters in which the gas contaminated air is passed through the fabric filters. The air pollutants in the air stick to the fibers in the fabric. Now the air pollution in Pakistan. According to estimate from the WHO Global Health Observatory, about 200 deaths per 100,000 per lakh population are attributed to environmental factors in Pakistan. The World Bank estimates that Pakistan's annual burden of disease due to outdoor air pollution accounts for 22,000 premature adult deaths and 1,634,32 uh, daily lives lost, while that of indoor pollution accounts for 40 million cases of acute respiratory tract infections and 28,000 deaths per year. The WHO Global Health Observatory estimates that about 30 deaths per lakh are attributed to indoor air pollution, while about 25 deaths per lakh are attributed to outdoor air pollution. In accordance with WHO guidelines, the air quality in Pakistan is considered unsafe. The most recent data indicates the Pakistan annual mean concentration of particulate matter of 2.5 micrometer size is 58 microgram per meter cube. That exceeds the recommended maximum limit of 10 microgram per meter cube according to WHO. See that it is about 6 times higher in Pakistan. Contributors to poor air quality in Pakistan include vehicle emissions, and that is a major component of the air pollution. Solid waste burning for cooking purposes in for domestic use and in industries and industrial emissions. Seasonal variations in pollution exist, with highest levels of air pollution in winter from December to March. Available data indicates that Peshawar, Rawalpindi, Karachi, Islamabad, and Lahore have consistently high levels of air pollution. According to data released by IQ Air, it is a global environmental think tank. Lahore is the most polluted place in the world, with the city's air quality index standing at 372 on this Monday morning. Now the turn for MCQs. First MCQ is, if an air pollutant released or formed in the atmosphere, which of the following will least likely result in long-term environmental damage to an ecosystem, whether it is ozone, mercury, lead, or carbon dioxide?
A.
Uh, Guess some other option.
Lead.
Carbon dioxide is the right option. Ozone is the main constituent of smoke, and it causes various health hazards like the mercury and lead. These also causes health hazard like lead causes neurological symptoms in children, while CO2 is less harmful as compared to these air pollutants. Ozone is formed by the chemical reaction of nitrogen oxides and volatile organic compounds in the presence of sunlight. Which one is true regarding it? Ground ozone is environmental. Whether ground ozone is environmental friendly or atmospheric ozone is bad. Ground ozone is hazardous secondary air pollutant, or it is a primary air pollutant. Which is the correct option?
C.
Yes, C is a correct option because ozone is a secondary air pollutant and it is at the ground level. That is the hazardous one. Carbon monoxide is considered as air pollutant in high quantities. How carbon monoxide emitted by automobiles prevents transport of oxygen in the body tissues? What this MCQ is for the mechanism of action of the carbon monoxide poisoning in health in humans. Whether it causes health hazard by changing oxygen into carbon dioxide, by destroying the hemoglobin, by forming a stable compound with hemoglobin, or by obstructing the reaction of oxygen with hemoglobin.
C. C.
Yes, C is the correct option because carbon monoxide has a about 300 times higher affinity to bond with the hemoglobin. The air pollutant involved in increasing the acidity of rain by a chemical reaction with rainwater, and a cause of acid rain is whether it is carbon monoxide, ozone, sulfur dioxide, or lead.
C. C.
Yes, C is a correct option because when sulfur dioxide reacts with water, it forms H2SO4, that is sulfuric acid, and it is the cause of acid rain. Which of the following air pollutant that is released by fuel combustion and volcano eruptions causing serious respiratory tract problems and is a culprit for yellowish discoloration of Taj Mahal? Whether it is carbon monoxide, ozone, SO2, or particulate matter?
C.
Yes, C is the correct option because when there is acid rain by SO2, it causes yellowish discoloration. Particulate matter. Uh, सारे अनम्यूट सारे ऑप्शंस हैं कि खुद ही कर सकते हैं? इधर से तो ऑप्शन नहीं है कि उनको अनम्यूट कर सकूं। अब हो गया अनम्यूट? ओके, आई विल सी इट आफ्टर कंप्लीटिंग द एमसीक्यूज।